Morning students, I am Sri Radhakrishnan, Assistant Professor in CS Department from Karnataka College of Engineering and Technology. Today we will discuss about third unit, intermediate code generation in concepts. Previous slides we discussed about the syntax analysis of the compiler design. Now with the compiler design subject, intermediate code generation. So now we go with the subjects. Next. So what is meant by intermediate code? So it is the fourth phases of the compiler, which takes the unordered parse tree as an input and produces the intermediate code. So it will take the form of unordered abstract tree or directed acyclic graph. Out of these two, any one will be the input to the intermediate code generator. So the intermediate code generator will produce the intermediate code in terms of low-level language in the form of three underscore representations. Now, so each and every instruction having at most one binary operation must be implemented. Most of the abstract machines instructions, there is no need for external memory. No specific hardware architectures and assumptions are not required. So intermediate code generations which is not using the external memory and as well as specific hardware requirement is not required. So it produces lower than the syntax. So this is the intermediate code generation. So mostly the intermediate code will be in the form of three address code representation. So what is the meaning of three address code representation means? It will each and every instruction of the given intermediate code, that means creation of the intermediate code, it's having maximum of three address reference only utilized. Generally, the syntax we called as temporary 1 is equal to temporary 2 operator temporary 3. So maximum T1, T2, T3 is three variables which is represented as a temporary variable which is stored in one particular memory location, corresponding variable memory location. So that this is a form maximum three address reference only we are utilizing. Minimum one operator is required and temporary variable must be utilized in each and every instruction. So a name for address may be in one of the form. The address values are called in terms of a name. The specific variable is possible. So each name is in symbol table index. For example, A is using means the corresponding A is present in the symbol table. Constant. There is the next case for constant. Some specific constant. For example, 10, 12, 13, whatever it is. And next, compiler generated temporary variables. Each time the temporary address is needed, the compiler generates another name is called as stream of T1, T2, T3. For example, we require temporary variable. Suppose consecutive temporary variable we require means we represent the name of T1, T2, T3 up to T9. So now, what is the usage of temporary variable in intermediate code generation means? The intermediate temporary names allow for code optimization to easily to move instructions. Easily we are implementing our code optimization purpose, the temporary variables are replaced. The target code generation time, these names will be allotted to register or memory. So this temporary variable is so easily to identify the target code locations is easily identified with the help of temporary variables. The address code instruction having some different meaning types. First, generally we represent as assignment instructions. X is equal to Y operator Z. It is a arithmetic operator, just direct assignments. Unary assignment is nothing but X is equal to operator Y. Copy instructions, X is equal to Y. So directly the value will be assigned. Unary operator must be utilizing means unary assignments. In terms of perform some operations and finally it's stored into some variable means that is assignment statements. So these are all the some three address code example instructions. Next, Unconditional jumps. Without any checking of any condition, the control flow will be varying from one location to another one target location. So that we call as go to L. So here go to operation is implemented in the 3 address code representation means the flow of execution is currently stopped and target will be the location L. So L is a symbolic label of the instruction where it should be the control flow will be what is the statement which need to be executed next. That particular address value will be pointed in the L locations or L symbolic labels. Conditional jump. Conditional jumps already we studied in C, C++ language or basic programming language itself. You have to perform some specific condition. Based on the condition, the control will be transferred. For example, if true, then else. If true condition is true means true statement will be executed, otherwise false statement will be executed. The same concept will be implemented. Conditional jump in terms of relational operator. If X relational operator Y go to it is maximum for Boolean operation results either true or false concept will be implemented and the next procedure call will be also possible for 3 address code. This will be discussed in the corresponding topic in in-depth manner. So indexed copy instruction. Indexed copy instruction means we have implementing for array values. So X is equal to Y of Y, the corresponding array variable Y, the corresponding index I. So for example, Y of 2 value is assigned to X. Or some value will be assigned to the specific index of the array. So that we call as indexed copy instruction. Address and pointer instructions. That means X is equal to ampersand Y means set of values of X to be location the address value at Y. Similarly, X is equal to pointer Y means probably Y is a pointer or temporary whose value is in the locations. So these are some 3 address code instructions for examples. Next one, translation expressions. So translation expression means how the instructions are evaluated, how the instructions are evaluated and transferred to some other locations generally. So S is here represented as a statements, ID is represented by some variables, E is represented by expression. So S gives ID equal to E means the corresponding expression will be initialized for the identifiers. So the generate operations, lookup of the lookup function will be used in the intermediate code generation. The lookup function is used to verifying the corresponding identifier which is present in symbol table or not. So lookup of top id dot next if it is available. So by default, initially the corresponding non-term E will be present in the symbol table, the top level that will be identified in the particular statements. Next, E gives E1 plus E2. So evaluation of the expression 1 plus expression 2, both are all evaluated in terms of addition operation. Finally, the result will be stored into some variable E, so that we can store the variable in terms of temporary. So we called initially E dot address value is pointed is equal to creating a new temporary variable, new temp operations. Next generates the execution code. E dot address equal to E1 dot address value plus E2 dot address value. So the value of E1 plus value of E2 will be added, finally stored into the E value. Similarly for minus E1, similarly for open bracket E1 close bracket and ID. So ID means the corresponding variable will be present in the symbol table or not. Boolean expressions. Boolean expressions means what is the value? Its relational operator will be executed. Boolean operation means we called as true or false. Different as a Boolean expression having different translation depending on their context. So compute logical values and also to be compute the flow of controllers. So the Boolean operations will be focusing on 2 values. First one is the computation value. Second one is based on the computation value, the flow of control also to be maintained. So what is the meaning of computation logical value? Means code can be generated in analogy to arithmetic operations for the logical operator. So based on the logical operator, the conditions will be verified. Along the flow of control means based on the condition, the Boolean expression can be used as a conditional expressions in statements. If, for, while, whatever it is, the flow of control also to be followed. Control flow expressions have two inherited attributes. What is the inherited attributes? Means the inputs will be, the attributes will be derived from their corresponding block or corresponding Boolean values. So that here we represent as P dot true, Boolean dot true value, B dot false value. B dot true label which contains that which control flow if B is true. The corresponding block B is true. Either block or condition is true means the true value will be executed. In terms of false label means which control flows to if B is false. If condition is false, the B false will be evaluated. So B false by is also is ended with S dot next means if B is false, go to whether address comes after the instruction is the completed. For example, if we represent a SA gives if B S1. So what is the expansion? S1 dot next is equal to S dot next is our expansions. This is a flow of control statements. How many flow of control statements we are having? For example, generally we call as if else, while we are replacing. If B condition is true, S1 will be evaluated. If condition, if else concept means if B state true statement, S1 will be evaluated. Else, S2 will be evaluated. In terms of multiple looping statements, if while B condition will be true, until the condition will be true, S1 will be evaluated. So that we called for first if B then S1. This is our first diagram for right top corner, which is represented by the if statements. If based statements means first we evaluate the expression B dot code. The B code will be evaluated. If the condition is true, having the two different possibilities, either true or false. So maybe true means true label will be evaluated, or false means false label will be control will be transferred. If the condition is true, what is that statement? S1 will be evaluated. So if the condition is true, P dot true label S1 dot code will be evaluated, executed. After that, control will be transferred to next level. Because our statement if B S1, else for there is no value, automatically if the S1 completed, automatically for next statement only evaluated. That means S dot next. If the condition is false, no need to be execute S1 code. So that B dot false points to the value for S dot next location. If the condition is true, S having true or false, S dot next is also having some value. If the condition is true, true statement will be executed. True statement will be executed. After that, S dot next value will be evaluated. If the condition is false, no need to execute S1 code, automatic control transfer to S dot next, so that B dot false value is assigned to S dot next. Next value, if then else. If else means if the similar concept, if the true code will be evaluated B value. If the condition is true, P dot true will be going for next instruction of execution. If the condition is false, P dot false value will be executed. So if the similarly B dot true means S1 dot code will be executed. After that, go to S dot next. If the condition is false, automatically B dot false points to S2 dot code. After the S2 dot code, there is no further elements, so automatically pointed by S dot next. Similarly for while loop, while condition, here while loop condition having some another information beginning because if the value will be looping operations. In terms of looping operation, we again control transfer to verifying the syntax condition. So B dot code will be evaluated, B dot true or P dot false. If the B is true, true statement S1 will be evaluated. What is the S1 dot next? The control will be again checking the condition, so that begin statement will be added as another one label, so that S1 dot code will be completed immediately. Go to begin. So begin statement will be again checking condition will be checked either true or false. True means S1 code will be evaluated. Next begin value going. Yeah, suppose condition is false, automatically B false statement will be executed. So this is the way the flow of conditions will be executed. So this is control statements. We are utilizing the flow of control statement translations. Flow of control statements. Control statements in the translation process. So P gives S means S dot next value will be creating a new label, and P dot code values. How the B will be evaluated? So P dot code is nothing but S dot code concatenation operation. Next, what is the process? Label S dot next will be created. Next, S gives assign means what is the value of evaluation? S dot code value is nothing but assign dot code. So now we focusing on if statement yes, if B S1. So now we have created, if the condition is true, true label will be needed. If the condition is false, false label is also required. So P dot true, create a new label. B dot false means automatically points to S dot S1 dot next. That is also S dot next. So what is the final execution steps of S value? That means S dot code is equal to, first we evaluate B dot code value. After that, label will be created. After the label creations, the corresponding S1 code will be evaluated. So S dot code means what is the true statements. If the condition is executed means what are the flow will be presented, that will be pointed in S dot code. So that S dot code, initially we check the condition, P code value will be evaluated. If the condition true the value, label true label value is created. After that, S1 code will be evaluated. Similarly, for S gives if B S1 else S2. Similarly, here two labels are created. B dot true is equal to new label. B dot false is equal to new label. So what is the S1 dot next is equal to S2 dot next is equal to S dot next, because S1 is true, automatically after the completion of S1 S next will be evaluated. If the condition is false, S2 will be evaluated. Once S2 completed, we go with S dot next. So that S1 dot next is equal to S2 dot next is equal to S next will be assigned. So what is the execution of the S value? S value is nothing but S dot code is equal to B dot code, true label created, S1 dot code. Next, S1 go to S dot next, label B2 created, S2 dot code, immediately go for S1 dot next, S dot next. So this is the way the flow will be presented. Similarly, for S gives while B S1, create a beginning label, create a true label. False label means S1 dot next is equal to, S dot next is equal to false value. S1 dot next what will be pointed as beginning statement. If S1 is completed, immediately control transfer to initial condition, so begin value will be assigned. So finally, S dot code is equal to label beginning, B code, label B2, B dot created, S1 dot code, go to beginning. This is the way the flow will be assigned and control flow will be translated. Similarly, for more number of concepts, so just we have a requirement for this basic if, else, then else condition is enough. That's all about our intermediate college Boolean expressions concepts.